actually join in. Okay, excellent. So good morning, good afternoon, good evening, everybody, depending on where you are in the world right now. I'm Pascal with ETH Global, and I have Taylor with me from SSV. He's going to be running you through this workshop today. Going to be roughly 30 minutes long. If you have any questions, just feel free to type them in the chat, and I'll answer them in between or at the end of his workshop. So ideally, keep your mics unmuted so everybody has the best experience possible. And with that, I would hand it over to Taylor.
Cool. Thank you, Pascal. Okay, I'll just go ahead and share my screen here. You can see that okay, Pascal / everyone? I will assume the silence is a yes. Okay, so yeah, I'm Taylor. I'm developer relations at SSVNetwork. So we are very happy to be sponsoring this hackathon. Today, I'm going to be going through a quick, pretty high-level workshop on building a restaking Dapp on SSV. SSV ourselves, we have 3 bounties for this hackathon, totaling to 10,000 USD. The 2 I'm going to touch upon today. First of all, it's mainly going to be on the best use, the restaking part of it, because that is the most interesting to us. And then I'm going to touch a little bit on the best enhancement to SSV tooling as well. If you're interested in the SSV data stuff, we do have a YouTube video that is going to be put up as well. I think it's going to be on the ETH Global YouTube as well. So keep an eye out for that, or you can just ping me about it if you're interested prior to that video going up. So first of all, I want to go through just a little bit about staking on Ethereum, because this is what SSV is all about. So for those who don't know, or probably all of you do know this already, Ethereum's consensus model is proof of stake. Used to be proof of work until the merge, and it was miners before, and now we're running with stakers. Staking itself is this act of depositing 32 ETH to activate validator software. So once you've deposited that 32 ETH to what is the staking contract, then your validator must run duties. So the validator always has to be online and always has to be running these duties and can't be misbehaving, or it could get slashed and you could lose out on some money, which obviously not good for anyone. So some of these duties are like 2 examples here. Are the most common ones as well are creating new blocks and proposing new blocks to be added to the blockchain. So that'll be validators, the software within them, processing the transactions, batching them together, and placing them in a new block. So for each time slot, 1 validator gets chosen as the person to do that. But while that's happening, the other validators still have jobs. So they need to attest these new blocks. And this means they need to verify that the new block and the end of the chain is all completely correct. So that's the 2 main duties that validators have to keep on going for, Ethereum to run correctly. So why would people stake? The first one is being that they want to earn rewards. Obviously, this is the biggest draw to it. People have, from years, have like ETH sitting around, and now they want to put it to use and help secure the network, which is the other big point. Staking cannot run correctly without a solid proof of stake network in place. So it's very important for the network that people are staking. A couple of types of staking here. The first one is solo staking. So this is, if I'm someone, I have 32 ETH, I want to get involved, I essentially will set up my own node or my own machine. On this, I will run, well, actually, first of all, I'll create the validator key. And on this, I will run execution, consensus, and a validator client. This is the 3 pieces of software that are necessary for the validator to run and to carry out the duties. I'll get to that more in the next slide. Pooled staking is more for people who do not have access to the 32 ETH themselves, because 32 ETH in today's in today's market is like, it's a lot of money. So instead of having 32 ETH, if there's 32 people and they all have 1 ETH, they can all pool it together and then go through the same process of what I was talking about above, about setting up a machine. And then staking as a service is essentially what it's called. So if you're someone who has the 32 ETH, or maybe you're one of those people who only has 1 ETH, but you don't have any technical knowledge or technical know-how, you don't want the headache pretty much of running a validator, you can give your ETH to this service. They'll do everything in the backgrounds. They'll take a little cut of your rewards, and then you'll also get the other cut of that. So what does it actually look like for setting up and exiting a validator? So the first thing I said there was about creating the validator keys. So this is generally done through Ethereum's deposit CLI, which I'll show later. When you do this as well, it's important to think about for this presentation that you need to set a withdrawal address. So this will essentially be some address. It can just be like a normal wallet, like your MetaMask or something, which you have control of, where you can take out the rewards that you've gained from staking. After you've got those validator keys, you want to set up your validator. So this is what I was saying about, the node, the machine, the validator keys on it, and you have those 3 pieces of software. Once everything is up and running and everything looks good, you can deposit your 32 ETH to the staking contract. Then you'll enter a validation queue. So essentially, anyone who's ahead of you, who's already gone through this process, they get first dibs on whose validator gets to become active first. And then after that, it's just kind of the job of making sure your validator stays online, keeps doing these duties, keeps sending the transactions, signing the transactions, sending them to the beacon node, and then getting paid out the rewards. Exiting to get your 32 ETH back is kind of a similar step. There's an exit queue as well, similar to a validation queue. So in the same way, it's like the first come, first served. You'll enter a line of people, but then after yours gets chosen, you can take your 32 ETH. So one important technology that SSV is pretty much based upon is called DVT. So we can think about this in terms of validator duties and why it's important. So on the left here is kind of what I was talking about already. If you're a solo staker, you come along, you create your validator, your validator key. It always has to be online, and you use these 3 pieces of software. There's a lot that can go wrong here, because the key always has to be online, and you always have to be ready to sign transactions for the duties. Means if you have like a power outage, for instance, and your machine is at your house, you're going to miss out on a bunch of duties, and you're going to lose money from that. Also, if there is some bugs in either the execution, the consensus, and the validator client, something that's out of your control, that is, just a problem with whoever created these clients, maybe your validator goes down, and while you're asleep or something, you can't do anything about it. You're missing out on duties. Also, I'm losing money again. Not good. Third point of this is the validator key always has to be online, because it's stored in this machine, and it always has to be active and ready to sign these transactions, which is a bit of a security risk. Compare this to DVT, this newer technology, which stands for distributed validator technology. So similar to the first step, we still need to create our validator key, but then we don't have to keep that key online. So what we do here is we split that validator key, in this example, into 4 operators. We split this into key shares. So each operator gets one of these key shares. These operators themselves are all running their own version of this validator node. So they run their own execution and consensus client. And in our case, the validator client, they'll be running an SSV client. This means that these operators can be spread out geographically anywhere in the world. Which means there's a lot of fault tolerance added, because if the power goes out in one country or something like this, the other 3 can still operate fine. Because the way this is designed, only 3 out of the 4 have to be online to sign the transactions for the duty. It means there's a lot of fault tolerance added here. Other parts of it, they can all use different execution and consensus clients. This is something that's really important for Ethereum and staking and the staking ecosystem, because diversity is really good. Because like I said, if there's some bug in one of these clients, like maybe in operator 1, there's a bug in the execution client, everything will still run fine. And when operators 2 to 4, and you can still carry out duties as a validator. So SSV ourselves, we founded in 2021, been in mainnet for around 1 year, and we've been in testnet for 2 years. So that technology that I was talking about, but in the previous slide, DBT, that we are the pioneers of that. We have been there since the very start. SSV actually stands for Secret Shared Validators, which was the original name of DBT, but it got changed a little bit. Currently, we've got around 40K plus validators, and 70% of them are using Eigenlayer or restaking. So a bounty like this is, I'm seeing some like good projects that we created is like very, very important to us. Around with those 40,000 validators, 900 operators are the ones managing those, making sure all the duties get carried out. And within that, there's 1.3 million e-staked. On top of that, we have the SSV token. This is very important for our network. It's very deep in the protocol, used for governance, first of all. So this is used by our DAO to vote on any important decisions. It's used for network fees, for the validators to pay to actually use the network. And it's also used for paying operators themselves, which I'll get to in the next slide. We also have a grants program, which is very interesting, especially for the people in hackathons like this. If you come out and you have this amazing project and you want to take it any further, and we see a lot of value in that for the SSV ecosystem, we can have that conversation after, and maybe we can build your project into, something fully fledged. So SSV network itself, what is it and how does it actually work? In short, we are this fully permissionless DBT staking infrastructure. And what I mean by that is if you are a staker or an operator, it's super simple for you to come along and join the network from either side. If I'm someone, I have my 32 ETH and I have it like deposited in the contract. If I want someone to, if I want these operators to run the duties for me, it's very, very easy for me to join up on the network and choose 4 operators and then have everything run for me. It's really good for people who don't want that, like I said before, don't want the headache of having to deal with all of the validator software. And this is very important, we are not a staking application itself. So we are the underlying infrastructure for staking applications to use. So a staking as a service, a staking service could be built on top of SSV's network. This provides, the validators and the customers with a much, much clearer and they can just be much more confident in the network and everything that's being run with this DBT technology because of all the reasons I talked about before. The staker and operator separation is very important as well. Just because, like I said before, it's super easy to come along as a staker or an operator and permissionlessly join the network. Restaking itself, it's essentially is staking and it just goes a little bit further. It can get pretty complicated, but I'm gonna just very, very dumb it down. So essentially it is, I'm a staker, I have that 32 ETH and I've staked it already. Now that 32 ETH can be allocated on Eigenlayer's protocol to other operators so I can get even more out of my staked ETH. This is done on SSV side through what is called native restaking from Eigenlayer side. So before I said we set that withdrawal address when we create the validator. When we want to set up with restaking, we want to create an eigenpod through Eigenlayer smart contracts, and we get an address for that eigenpod, and we will set that as the withdrawal address. SSV also it's non-custodial, so that means any restaking protocol, even if it's not Eigenlayer, it can all come along and be plug and played with anything else. What I already talked about below the bottom half of this diagram was just the normal SSV flow. You come along as a validator, or as a staker, you register your validator and you choose your operators. The only difference to enable restaking is that you need to set your withdrawal address to this eigenpod. This is a small preview of what it looks like on the Eigenlayer website as well. So this is me set up on testnet. I created my eigenpod. I register on SSV on the web app, and I chose 4 operators. So now that's all up and running. And because I set the withdrawal address to this eigenpod, I was able to delegate my 32 ETH to this operator here, Satoshi. And then because I can still get my withdrawals, because it's the withdrawal address is set to the eigenpod address, I just need to withdraw a little differently through their website. So gonna go through a brief walkthrough now on it's essentially going to be a high-level manual walkthrough of what the actual process is of creating an eigenpod, creating your validator keys, how to register on the SSV network, and then a small bit about depositing to the staking smart contract. So as I go through this, I'm gonna mention the tools that can be used to build this, because as you'll see, this is like it's not a very complicated process. It's not a very lengthy process, but the fact that it isn't it all in one place and some nice UI where everything is able to be done, smoothly and succinctly, is essentially why we've put up this bounty. So first thing that is done here, on the Eigenlayer website, I'm doing everything on the Holesky testnet, by the way. So the first thing we need to do is we need to generate our eigenpod address. So super simple. What's happening here is I've connected my wallet and I'm just doing a smart contract transaction here. So what this would actually look like programmatically, I have done a little bit here. So yeah, this is the Eigenlayer contract address on Holesky. And this is the function here that's getting called when I click through their UI. So this is just an example of what you could do programmatically to get this to work for your first step. Because we need to get this address as well, and we need to pass that into the deposit CLI when we're creating our validator keys. We also can, where is it? Yeah, we can call this function here after the get pod address. So that'll return our address, which essentially is this address here. Once we have that, we want to create our validator key. So I won't spend too much on this, but the most simple way to do this is to use this Ethereum staking deposit CLI. You can go down here, you can download whichever operating system you're using. So I've already run this here just to save us a little bit of time. But essentially I've just run it here with this deposit mnemonic. I just created one validator. I want it on Holesky. The important part here for restaking is that this ETH1 withdrawal address is set to our new eigenpod, which is what we've created here, and got back from the Eigenlayer smart contract. Once you carry this out, and you complete creating the validator keys, there's two things you'll get here. One of them is this key store. So this is what's important for us. So with SSV, using the tools that we have, this is what we'll split. This is the private key or the private key file that we will split into. Oh shit, my glasses. We'll split into 4 different shares to give to the 4 operators for them to use. The deposit file, it's used when we're actually depositing our 32 ETH to the staking contract. So I'll first of all go through it on the SSV web app to see what this looks like, and then I'll speak about the tools that are being used as well. So I come along to the SSV web app. I've created my validator keys, or my validator key store like I have here, and I want to distribute this validator to the 4 operators, and I want them to run the operator for me, or to run the validator for me. Yep. So I'm gonna click generate new key shares here, because I already have the key store. And that's an important part to think about. We have the key store, which is generated from the Ethereum, the validator keys, but the key shares are the DBT SSV specific stuff. So I'm just going to click some random operators here. As you can see in the SSV web app, we can see their performance. We can see how much they cost. For the purposes of this, and because it's testnet, it doesn't really matter what I click. Oh yeah, and one thing I actually forgot to mention, a prerequisite of this is that you need some of the SSV token to carry this out. We have this faucet.ssv.network where you can get free tokens in testnet. So here I want to just continue to generate my key shares. So what I'm going to do here is I'm just going to drag in this key store file that I created earlier. We can see that it's valid. Then I'm going to enter in my key store password. So this is what something you would put in when you're when you're generating the validator keys. I want to select my funding period, so I'm going to pay 0.5 SSV, and that means I'm going to pay the operators this much. So they will operate and run the duties for my validator for the next 6 months. Just click through this bit because it's not so important right now. And I'll approve SSV as we need to do this for the first time we're working with an ERC20 token. So what was happening in the background there, though? I put in the key store file, and the key shares are getting created onto the operators that I want. In the background, it's using this SSV keys SDK. So this is what you're going to use after you get the key store file. There's some examples here, and there's a good example here. So essentially what will happen here is we take the key store and the key store password, just like I put into the UI there. We'll create the key shares using our build shares function. And then towards the end, if we have it here, okay, I have it on my own code actually. I have it on my own code that, yeah, we can actually build the payload here itself. So this is the actual contract transaction that we want to send to the SSV smart contract. The smart contract details themselves, it can be found on our docs as well under this developers/smart contract section. So it's this SSVNetwork smart contract that you're going to be working with. Last thing here is just to register the validator. And while we are waiting on that, I'll give a small look at what the very last step looks like. So I said about depositing the 32 ETH. This is the kind of user-friendly way of doing it through the Haleski Launchpad. We can skip through the execution in the consensus client because we don't care about that, because the operators that we've chosen are the ones who are going to be running the software. I can skip through this as well because we generated the keys themselves. But this is the important part. So when you're doing the deposit, and if you're going to do the deposit programmatically, you're still going to need this deposit file here. I don't have 32 ETH testing, or no, I'm doing this well, but yeah, essentially with this, we can do the deposit, and then once we have our validator up and running and registered on the SSV network, we're good to go. We can chill out. We've paid our 6 months, and that's us ready to go. So for the restaking part of it, the most important part is setting that withdrawal address when you create the validator key. And then with the SSV part of it, you just want to, when you choose your operators, have that key, the key store file, so we can create the key shares and register on the SSV network. This says inactive because I haven't deposited to the staking contract yet. And yeah, I think that's it for that part of it. So hopefully that manual walkthrough makes sense. Like I said, the current setup of it is a lot of jumping around. I need to go to a bunch of different applications, run some CLI command as well. We were able to have that done programmatically and some nice UI, combine it all together. That's exactly the sort of thing we're looking for in this bounty. The other bounty I briefly want to touch on is the SSV tooling bounty. So some of the current tooling limitations that we have are, the first being bulk registration limits, and the other being technical barriers. The first one is this validator registration. So as you can see there, me going through and registering one validator in the web app is like a very simple process, because it's like one key store file, I pick 4 operators, and that's it, just send the transaction. This can be done with a lot of validators at a time, because instead of just using the register validator function, we also have a bulk validator registration function. But this also has its limits. One of them being here. So like if I have 80 of those key shares and I want them with 4 operators each, this is what will fit in the transaction. It's not limited by us per se, but this is all we can send in one transaction on Ethereum. So we kind of pose with this question, what if we want to distribute thousands of validators in bulk? This is kind of a problem we currently have, and if people are looking for some interesting ways to fix it, this would very, very much help us, and it'd be a great way to participate in this bounty. The other being the key shares generation. So as I said, I generated the keys through the CLI. The other way to doing it is through DKG. So we have a DKG client, which essentially means we create we create the key shares and we create a public key, but the private key is never shown, or it's never given to anyone, only the key shares, just to add an extra layer of security. So like with this generated in through the CLI, we do a little bit in the web app, and then it provides a Docker command. Now, if I'm a non-technical user, but I want to run a validator, even like using the CLI or even trying to get Docker up and running so I can run DKG, that can be very difficult for the normal person. So another problem we have here is that, if I'm essentially what I just said, if I'm a non-technical user, how do I get this done? So another really good way to approach this bounty would be looking at those sort of problems, like how can I make this easier for someone who doesn't really know what's going on, or doesn't know much about tech. So a brief summary of what we went over. Hopefully we've learned a little bit about staking on Ethereum, more about DVT, distributed validator technology, which is what SSV works on. Hopefully you've got some ideas on what you can build. That hopefully that manual process that I went through has painted a picture in your head of how that could be put together into something amazing. I walked through a bit of the tools, what could be used to build it, and went through the other bounty as well, about improving the tools. So if that tickles some other people's fancy. So where to get help? There's one where me and Massimo mainly will be, who's the other DevRel, will be in this partner chat in the Discord, in the ETH Global Discord. Or if you want to DM me on Telegram any time of the day, just like hit me up if that's easier for you. And yeah, some resources here. So just like our docs as well, pretty much everything you need is going to be on the docs. And if it's or not, or if you have any queries with it, just come to us. And yeah, this is the link for the testnet version of Eigenlayer, to generate those eigenpods. And yeah, that's the end of the presentation. Hopefully that was really valuable for some people. We're really excited to see what people build. If you have any questions at all, not even regarding the bounty specifically, like if you just want to know more about DBT, or there's some things I didn't explain very clearly, like I'm happy to talk to anyone, let you know what's going on. But yeah, really hope people want to build with restaking or improve our tools, or maybe in the SSV data. We're really excited for people to build with it because we haven't done a hackathon in like 2 years or something. So yeah, I'm gonna stop sharing now. Not sure if there's any questions in the chat. No, it's all AI bots or something.
Yeah. Yeah, so far I don't. So if anybody has a question, can just put them in the chat right now. Still technically have 1 minute. We can go a bit over if it's required, but also feel free, as Taylor mentioned, just to drop a message in the Discord, use the partner channel, or just approach them directly. I can generally recommend posting something in the open because other people can jump on that too. Oh, we do have a question here from Rashid. How is the key split exactly?
How is the key split exactly? I'm gonna have to maybe link you something on that because I don't really know the actual ins and outs of how it's done cryptographically. But we definitely have that in our docs, and I can like DM you that after Rashid. I just don't know it off the top of my head. Oh, one thing I meant to add actually is that Eigenlayer, I meant to say this at the start. Eigenlayer have what is called an infinity hackathon going on. So anyone who builds with Eigenlayer and, in this project, essentially you are eligible to submit to their infinity hackathon as well, which is just running at all times. But yeah, so if you build with Eigenlayer and restaking in this hackathon, potentially you can make more money through Eigenlayer's infinity hackathon as well. So if you're interested in doing this or are going to build with restaking, I would highly recommend you submit to that as well because they will be very interested.
Okay, sounds amazing. Okay, with this, I would wrap this up. Thank you very much, everybody attending, and thank you, Taylor. That was a great one. Looking forward to seeing what people are going to be building with SSV and some really, really cool stuff. And thanks to the AI bots. Yeah.
Yes, thanks, guys. Shout out to my AI fans in the chat.
All right, everybody. Have a good one.